Today we're going to be reviewing alligations. Alligations are when two percent-based products are mixed to create a third percent-based product. I'm highlighting that two products are mixed to create a third because a similar problem would be dilutions. Dilutions are when we manipulate 1% based product to make a second. I don't want you guys to get confused between these two problems. So just remember that with alligations, we're mixing two different percent-based products to create the third percent-based product. And we're usually trying to figure out the amount of milliliters of one or both of these percent-based products that we're mixing. So to solve alligation problems, we're going to start with a tic-tac-toe board. So in the upper left, we're going to put the higher percent that we're mixing. In the lower left, we're going to put the lower percent that we're mixing. And in the middle of the tic-tac-toe board, we're going to put our percent to make. We're going to subtract diagonally, so we're going to subtract our lower percent to mix by our percent to make. And we're going to put that amount here as a positive. Then we're going to take our higher percent we're mixing, subtract that by our percent to make. We're going to put that number here. And once again, we're going to put it as a positive number. This number will be your parts of your higher percent. And this number will be your parts of your lower percent. And I know that's a little bit confusing because in order to get this, you're starting with your lower percent. And in order to get this, you're starting with your higher percent. But you can just remember that anything on the top of the tic-tac-toe board is your higher, and anything on the bottom of your tic-tac-toe board is your lower. So in pharmacy, if you are solving any type of percent-based problem, you need to work in either grams or milliliters. This is because percents are expressed as gram over gram, milliliter over milliliter, or gram over milliliter. If you're given any other units besides gram or milliliter, you need to convert to gram or milliliter before solving your problem. Okay, so the example is how many milliliters of 70% and 30% solutions will you need to mix together to create 200 milliliters of a 60% solution? So let's set up our tic-tac-toe board and get to work. First of all, we want to know how many milliliters of 70% and 30% need to be mixed to create 200 milliliters of a 60%. So in green, that's what you need to mix. And in yellow is what we're looking for. So I'm going to take my higher percent to mix, write it over here. I'm going to take my lower percent to mix, write it over here. I'm going to take the percent I want to find and put it over here. And then I'm going to subtract diagonally. So 70 minus 60 is 10. 60 minus 30 is 30. We always want to leave these values as positive numbers. So let's just say you subtracted 30 from 60. You would get negative 30, but we still always want to put them as positive. So 30 and 10. Now you add the two numbers on the right. So 30 plus 10 equals 40. So The 30 and the 10 are parts. The 40 is the whole. So that's needed as we move along. So as I said, the 30 right here is part of the 70%. And the 10 right here is part of the 30%. So let's start off with solving for 70%. Sometimes you might just need to find how many milliliters of 70%, how many milliliters of 30%. It's still good to find both because then you can kind of double check yourself, which I'll discuss later. So first off, 70%. So we're going to take our 30, the part of the 70%. We're going to put it over 40, which is our whole, right here. We're going to set that equal to, and we want the total volume we're trying to find. So the total volume we're trying to find is 200 milliliters. So we're going to set that equal to 200 milliliters. So that's our total over X, because we're trying to find that part of the whole. Now let's cross multiply. Divide both sides by 40 to isolate X. And we get 150 milliliters of 70%. Now let's solve for our 30%. So here we have 10 part of 30% over the whole of 40. So 10 over 40. We're going to also set that equal to X over 200 milliliters because we're still trying to find for that total volume of 200 milliliters. Cross multiply. Divide both sides by 40 to isolate X. And we get 50 milliliters of 30%. Now if we add these two values together, we should get that total of 200 milliliters because we're supposed to be mixing these amounts to get that total volume. So 150 plus 50 milliliters equals 200 milliliters. So this checks off. So if you're running short on time on the CERT test, that's one way that you could do this. If you need to find both values, you could always subtract whatever value you do find from the total that you're looking for, and that would give you your other value. So let's just say we just found that 150 milliliters of 70% is what we need. And we're running short on time and we don't have time to calculate for that 30%. You could just take 200 milliliters, the total that we need to find, and subtract that from our 150, and then you would get that 50 milliliters of 30%. So the two amounts that you're trying to mix should always equal your end result. So our next example is how many milliliters of 70% and 40% solutions should be mixed to prepare 0.3 liters of a 60% solution. So first off, I'm seeing one important thing we need to do. Remember, any percent-based equation must only use gram or milliliter. So, liter, we would need to convert that to milliliter before we can solve. So, let's do that. So I'm going to do that using my acronym, Keen Henry died by drinking chocolate milk Liter is our base unit, so we're going to move our decimal point 1, 2, 3 loops to the right. 0.3, 1, 2, 3. Fill in zeros for our loops. So now we have 300 milliliters. Okay, so let's continue with our problem now. So how many milliliters of 70% and 40% solutions should be mixed to prepare 300 milliliters of a 60% solution? So in blue is what we're trying to find, and in yellow is what we're mixing. Let's draw our tic-tac-toe board to get started. So remember, the higher percent that we're mixing is 70 and the lower percent is 40. So I'm going to write my 70 in this corner, my 40% in this corner. And the amount we're trying to find is 60%. So I'm going to write that in the middle. Now let's subtract diagonally. Is 20. 70 minus 60 is 10. Let's add these and we get 30. So remember, this 20 is our parts of 70 and this 10 is our parts of 40. And together, these equal 30. Let's set up our ratios now. 20 over 30. Set that equal to our total milliliters that we're trying to find, which would be the 300. And now let's cross multiply. Divide both sides by 30 to isolate x, and we get 200 equals x. And this would mean that we have 200 milliliters for our higher amount. Since we're using the 20, we're starting with our higher amount, and that would be of 70%. So we need to mix in 200 milliliters of 70%. Now, we need a total of 300 milliliters. So 300 subtracted by 200 milliliters. We already have the indication that our 40% should be 100 milliliters. Because our amount of 70% plus our amount of 40% should equal the total volume we're trying to find. But let's just solve it, just in case, just as a way to double check ourselves. So let's take our ratio, the ratio right here, 10 over 30. Set that equal to x over 300 milliliters. And let's cross multiply. Divide both sides by 30 to isolate x. And we get 100 equals x, which is what we wanted. So 100 milliliters of 40%, which is what we want to mix. So we have 200 milliliters of 70% and 100 milliliters of 40%. So 200 plus 100 equals 300 milliliters, which 300 milliliters, remember, is what we found that we needed from our original problem. So this checks out.